let me discuss about the applications of the microcontroller. I mean, how we are going to use for the real-time applications. See here, just a single microcontroller is not sufficient. To perform in real-time application, we need some external devices need to be connected, like such as you want to give any input, we need a keypad. To see the output, we need LCD, 7 segment or LEDs, displays. And to convert analog to digital, because the physical things are available in analog, we need to convert it to digital, we need ADC. Once again, to drive the devices in real world, that is required the analog signals that we need to convert to digital to analog conversion. These are the minimum the devices that is required, and interrupts, as we discussed interrupts concept in the previous, the purpose interrupt to speed up the performance. More than one functions can be performed with the help of interrupts. Now let us see one by one. The real time, as I said, the real time application can be designed and implement using 805 microcontroller based system. The interfacing input and output devices. Input device like linear keys, matrix keys, keypad. It may be arranged in linear form or in matrix form. Then toggle switch, it may be, or push button switch. Then output device, it may be LEDs. See, certain cases, even a single LED will give a lot of information. Like, for example, if you use a red LED, for example, something error in the system to display that red LED, it will give a particular segment place there is an error. So, like this LED can be used to detect easily an error, to debugging it will be very easy. Then suddenly you can able to get the information. Like for example, the adapter, we have a LED, just like one LED, if it is that blinking means there is a power is there, like that. Then we have 7 segment display. 7 segment, it is suitable for displaying the numbers. So if you want to display character and all, we go for a matrix LED form, or we can go for LCD. LCD is advantage, consume less power, but its range is very less. Range is very less. So far distance we can't see the character on LCD. The keypad, as I told, this is in the form of a matrix form. They are arranged rows and columns. The keypad keys. So like they are arranged in rows and columns form. Then we have 7 segment display, as I told. 7 segment display is suitable for displaying the numbers. Is having 7 segments, like 7 LEDs. I mean 7 diodes, light emitting diodes. These are LEDs. A, B, C, D, E, F, G, H. H is nothing but decimal point. Okay. So there are 2 forms is available: common anode and common cathode. Common anode means all its anode is connected to common. Left cathode open. This cathode will be driven by controller, or it may be a common cathode. Anode will be left open. That is dry. It will be the controller output will be given as here as an input for this segment. So like this, you can display the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in this form. The corresponding LED should glow. So this is interfacing for 7 segment display. And similarly, you can see here the corresponding values to be given to display 0. For example, 0, G is 0. Remaining all will be 1. This is a common cathode. So means whenever it is 1, that particular LED will glow. So like this corresponding number you have to send. So you have to get the display 0, 1, similarly 2, 3, 4, like that. So we can get the display. Then similarly, this is interfacing, how we are going to interface this 7 segment, and how we can able to interface the keypad. The diagram will give the idea. Here is the program for numbers displaying 0 to 9 with some delay. Okay, so we can delay is must. We can able to see. If there is no delay, we can't able to see the numbers because our eye cannot able to recognize the fast after one number displaying next. There should be some gap is required. So now similarly the program for to detect the key pressed forecast for matrix keypad and display and seven segment written here program for that to get key to identify the key pressed then corresponding rows and columns. From that we are going to send to the seven segment display. Then similarly the LCD display LCD we have a command set of commands and before displaying the character on LCD, we should have to configure by using these commands. Okay, and we have the 8 data lines and we have 3 control lines: register select, read write, enable. Register select is distinguished. Are you going to configuring the LCD or displaying the data on LCD? Read write, are you writing or reading the data towards the LCD? If writing to the LCD or reading from the LCD. So here we are going to write all the functions, but there is one function to read the status. Here we are not using this programming. Then enable always high to low signal has to be given. To perform any operation, enable should be send a signal. And these are the data lines. Data to be the numbers to be sent to the LCD by using these data lines D0 to D7. These are the pins as I explained you. Select, read, write, enable. Here how we are going to connect from controller to the this LCD. You can even connect the 4 lines also. Here the program for LCD. So we have to configure by sending these characters. 38 2 lines and 0E clear 01 cursor. Then C0 second line display. See here all functions into there. Here the command 0C display on cursor off. 01 01 clear the display screen. 01 we used, 0C we used, and 38 we used. 2 lines, 5 cross 7 dot matrix. These few required commands we are going to use to configure the LCD first, then you set the data. So for configuration, we need to have the LCD command means RS should be 0, rewrite 0, enable high and low. Similarly, for data, RS is 1, remaining all conditions should be same as for sending command data. So this is a delay program. Like we are going to send one by one first configuration number, and later the character to be displayed, we need to send. Okay, this is for LCD interfacing. Then this ADC already discussed. ADC with an example. Similarly, is a ADC in detail here. How ADC can be interfaced. This is 808 ADC. So this is all startup conversion, end of conversion, output enable, ALE. This is uh, for selecting a particular channel. Here, more than one source can be connected. Here, input that can be done with the help of this ABC. An interrupt, as you know that we are discussing interrupt. Interrupt is an external or internal event that interrupts the microcontroller. We inform it that a device needs its service. The device required service from the controller. A single microcontroller can serve several devices by 2 ways by using interrupts. Can serve several devices by using interrupts. So whenever any device needs its service, the device notifies the microcontroller by sending it an interrupt signal. Upon receiving an interrupt signal, the microcontroller interrupts whatever it is doing and serves the device. That is the what is going to happen whenever interrupt occurs. Interrupt and polling. Polling is nothing but continuously checking, wasting the time. Interrupts we use, we can avoid simply wasting. The interrupt service routine is nothing but the the program to be executed whenever interrupt occur. Whenever interrupt is invoked, the micro runs the interrupt service routine. So this is fixed location in memory. What is the address of its ISR? Okay, that is called interrupt vector. These are the steps. Once, whenever an interrupt occur, the microcontroller goes through. It finishes the instruction it is executing and saves the address of the next instruction onto the stack. Then it saves the status, current status of all the registers internally. It jumps to the fixed location, that is a vector location specified. Then after that, gets the address of the ISR from where it has to start execute the ISR program. And it go first, it will go to interrupt vector table. From there, jumps to the ISR and execute the interrupt service routine. The last instruction of the subroutine will be always there is a for ISR routine will be RETI return from the interrupt. Upon executing this RETI, the microcontroller returns the place where it was interrupted. It has to once again resume back where it was interrupted. So by getting the address from the stack to the program counter, it starts execute from that address where it was interrupted. This is how the procedure to be it is going to follow whenever an interrupt occur. These are 6 interrupts already I discussed. What are all these reset 2 interrupts for timer, 2 external interrupts, and 1 serial communication interrupts. These are the vector addresses for each interrupt reset, external timer 1, and serial communication. As already discussed in this all, this is how this each one will be. So enabled more than one interrupt. So I can have so this interrupt register. We can set all this so that it's going to generate an interrupt corresponding device sequence.